Welcome to Lecture 4 of Networks, Friends, Money, and Bytes. And today's topic is Netflix. Let me first warn you, though, that throughout this course of 20 plus 1 lectures, if you plot the length of the video lecture against these 20 lectures, they go up and down. The average might be 75 minutes across all the modules. So they may go up and down, if I interpolate. Now this lecture 4 is actually going to be, by far the longest lecture. You will see that we have quite a few modules, and each module is kind of long because we have to introduce both the concepts of collaborative filtering, individualized recommendation by scaling out the system, the network, as well as the mathematical language of more optimization theory. Again, if you plot the level of mathematical difficulty involved, or the amount of symbolic operation involved against these 20 lectures, so they go up and down quite a bit, actually. I'll say that this lecture is perhaps by far the most mathematical one. If you can pass this lecture, you probably can face any of the remaining mathematics throughout the rest of the course. So to some degree, we're climbing up a hill today, and this hill is both conceptually little involved and mathematically will require some hard work, as climbing up a real hill would demand. But if you can climb through this hill, then the rest of the course should be actually much easier, especially on some of the lectures coming up. Now, having said that, let's first review what we had in the past 3 lectures. We saw 3 beautiful equations, and they are very useful equations too. The first one was in lecture 1, DPC, distributed power control used in 3G CDMA data networks. And it says that for each transmitter of logical pair I, the transmit power P at the next discrete time slot t plus 1 should be whatever it is right now, P sub I of t, times a gain parameter. And that parameter is the ratio between the target SIR gamma and the currently achieved SIR of this link. Now this does not change over time as far as this algorithm is concerned. It is a constant, and this varies over time as different people change their transmit power level. And we saw that this is essentially an implicit feedback signal telling you whether you should increase or decrease your power. And the second equation that is beautiful and useful we saw in lecture 2 can be summarized as following. That is the payoff function for the ith bidder in an auction. U sub I is a function of all the bidders' bids, just like the SIR is a function of all the transmit powers. It's a vector B. And it is the difference between your private independent valuation V and the price you have to pay, which depends on all the bids. And this function, the price, which is not the power now, the price as a function of all the bids, the shape of this function is determined by the designer of the auction. And for different kind of function P of B, you will induce different kind of behavior by the bidders. They will bid different BI star, the optimal according to some metric B. For example, whatever maximizes the utility. Now, of course, this is assuming you actually win the allocation. If you do not get the item, then the utility is 0. This definition of payoff function, which also highlights the fact that you can design the auction and that will induce different bidding behavior, is the second equation. The third one, which we touched upon last lecture, can be written as the following. Simply the vector pi star transpose equals pi star transpose times G. This is the Google matrix that we defined last time, and it is defined in such a way that the corresponding eigenvector corresponding to the largest eigenvalue of 1, can be uniquely defined and efficiently computed. Okay, so this defines that Google PageRank score, which further leads to the rank ordering of the web pages. Now, if you count how many times DPC is used in the mobile world, if you count how many times auction is used in many contexts, including the online space, if you count how many times the Google PageRank is used every time you search on Google, you can tell these three are powerful equations. They're simple, but they're very, very widely used. So now we're going to continue this track of 4 lectures. We talked about power control, distributed protocol. We talked about second price auction, talked about PageRank, and now collaborator filtering for recommendation, like on Netflix. And these 4 lectures also introduce the language of optimization, then game, then graph, and now learning theories.